In order to differentiate this function, we have to use the quotient rule. So we have f prime of x. Sine prime is cosine times the denominator minus. Of course, I don't have enough room there, so I'm going to just remove that. So f prime of x, sine prime is cosine x, 1 plus cosine x minus sine. And differentiate the denominator, 1 is 0, 1 prime is 0, cosine prime is negative sine. So I'm going to put plus sine squared over 1 plus cosine x, everything squared. Do not simplify something like this. That would be terrible, because this is not a factor at the top. So then what I need to do is just distribute and see if I can simplify a little bit. We have to distribute. It's not something complicated, and we have to try to simplify it a little bit. Okay, so then when I distribute, I get cosine plus cosine squared. Something is always crooked here. I'm not sure why. Anyway, so 4. So we have cosine x plus cosine squared x plus sine squared x over 1 plus cosine x, everything squared. But as we know from a long time ago, this is 1. So then we have 1 plus cosine x in the numerator and 1 plus cosine x squared in the denominator. I simplified the entire factor. Please put 1, because if you don't put 1, you may consider it 0, and that will be a terrible mistake. So it's 1 over 1 plus cosine x. So that is the simplified form of this function, the derivative of this function. Okay, so the next item on the agenda is section 3.11, hyperbolic functions. And I wanted to share my screen for a moment with you. And I'm clicking on the ebook. Okay. This is the last section of chapter 3. We still have a lot in chapter 3, but we need to look at it before we continue with implicit differentiation, only because there are just some functions called hyperbolic, and all we want to do is look at their derivatives. So we're going to add more rules, more formulas to the list. Okay. In short, I just want to go back to a couple of graphs. And first of all, before the book gets there, so hyperbolic functions are not trig functions. They're not trig functions. And you can say, okay, if they're not trig functions, why the name is hyperbolic sine, hyperbolic cosine, hyperbolic tangent, hyperbolic cotangent, hyperbolic secant, and hyperbolic cosecant. Why are they called this way if they're not trig functions? Because they have some similarities, and the correspondence and the relationships among them have some similarities with trig functions, but they're not trig functions. So what about sine, hyperbolic sine? It's a combination of exponential functions, actually. It's e to the x minus e to negative x divided by 2. So as you see, it's a difference of exponential functions, one with power x, the other one with power negative x, everything over 2. Cosine is the same, but with plus here. So hyperbolic cosine, e to the x plus e to negative x divided by 2. Hyperbolic tangent is sine over cosine. Hyperbolic cotangent is cosine over sine. Hyperbolic secant is 1 over cosine. Hyperbolic cosecant is 1 over sine. So that's why we use the names of sine, cosine, tangent, cotangent because they have similar relationships. Okay, so now I'm going to share my screen and just want to go back so you can see the graphs. And why are they needed? I'm not sure why my arrow doesn't work here. Okay. Not the inverse trig, not the inverse hyperbolic just yet. Hyperbolic functions and their derivatives. So we're going to get to that in a minute. So first I wanted to show you the graph of hyperbolic sine. Kind of similar, but it goes to negative, it comes from negative infinity, it goes to infinity. But it's kind of similar to sine a little bit. A little bit. Here is hyperbolic cosine. You can say it looks like a quadratic function. Yes, but the quadratic function did not fit the requirements. But this function did. What requirements? Okay, here are two examples. You can say we don't do this anymore. Everything, all the wiring, it's underground now. What are you talking about? True, possibly. But all the high-powered lines, we still see them from pole to pole. So this fit the hyperbolic cosine function exactly like you see it here, with a number and another number and x over this number. So they calculated it so that it doesn't fall, it doesn't move, it fits correctly between the two poles, and the function, this piece is part of this function that has hyperbolic cosine. A quadratic didn't work, another polynomial didn't work, trig didn't work, nothing worked. Log didn't work, exponential didn't work. This is the one that is used. Okay, here's another. For water wave, this is also a function. And the function uses hyperbolic functions. Okay? So this one uses hyperbolic tangent. So these are two applications in which no other function worked. Now, how do I determine, let's say if I want to determine hyperbolic sine of 5, I have one option with e to 5 minus e, that's the formula, to negative 5. I don't like that. I like parentheses, but never mind this time. Divided by 2. Or I have another option with a catalog. So activate it with second, catalog, and then click on hyperbolic sine, just S, basically, right here, this little S. And then, because it jumps from the beginning to S, and then you still have to, by hand, here it is. And that's how you call it, hyperbolic sine. And I put 5 in it, and when I click enter, I should get exactly this gibberish, whatever that is. Okay? So, or you either use the formula or you use the catalog. What about if you want to determine cotangent? Then you find sine and cosine, or you go to and divide them appropriately, or you go to second and catalog and look up cotangent, hyperbolic cotangent. Okay, back to the book. So now what I wanted to talk about is the derivatives of these functions, and then apply them in different situations, in different applications. So let me go back directly to 3.11. Okay. So the nice part here is that hyperbolic sine prime is also hyperbolic cosine, and hyperbolic cosine prime is plain, not minus, but plain hyperbolic sine x. And these can be determined very easily, right? So if I want to determine tangent, I put sine over cosine, hyperbolic sine over hyperbolic cosine, and find the formula for tangent, hyperbolic tangent, and so on and so forth. So what are the rules? I'm not going to ask you for the inverse trig, I'm sorry, inverse hyperbolic, but at least the derivatives of the regular hyperbolic functions. So sine prime is cosine, cosine prime is sine. Of course, tangent is the same. Hyperbolic secant squared. And cotangent is negative hyperbolic cosecant squared. So the same thing, no change. It's just that that h is in the formula right now. It's just that the last two have both minus. So hyperbolic secant should be secant tangent, but it's negative. And so it's negative hyperbolic secant hyperbolic tangent. And the last one, so the hyperbolic cosecant, is also negative. Both of them are negative. So negative hyperbolic cosecant, hyperbolic cotangent. So the formulas are very, very similar. The first three, this one is not minus but plus. This one is exactly the same. This one has minus, and this one is exactly the same with what we know. So I'm going to share my screen and let's take a look. Of course, we can determine limits as well, looking at graphs, but I'm more interested in how we differentiate. So find the derivative from 35 through 53. Please choose, or I will.
Can we look at 38?
Yes, of course. So I'm on page 5, and you said 38, correct?
Yeah.
Okay, here it is. So we have g of x, which is hyperbolic sine of x squared. Oh, hyperbolic sine. I'm copying something else. Sorry about that. So that's not it. So let me just do this. I was copying 37. So in 38, g of x equals hyperbolic squared of x. Perfect. Good. So like before, g prime, we have to start with the outer function. This is the outer function. So let's differentiate the outer function. What do I have to write? Please contribute, please. Please say something.
That would be x to the power 2, right?
2.
Or yeah.
Hyperbolic sine times the inner function prime, which is, so to 2 minus 1, but it's power 1, times the inner function prime, which is?
E to the power 2 minus e to the power of negative 2.
That's fine.
We do not go back to e. So we just wrote here that hyperbolic sine prime is cosine. So hyperbolic sine squared prime is 2 times sine 2 minus 1 times the inner function prime, which is cosine, hyperbolic cosine. Is that okay?
Yeah, I get it now.
Perfect. So let's take a look. Let's look at other examples. What about 45? In 45, we have g of t equals t cotangent, hyperbolic cotangent of the square root of t squared plus 1. Okay. Anyone would like to get us started on this, please? Anyone, please? So let's just start it and then we'll continue with somebody else. So how do we start? First of all, what do we have to apply here? What rule applies here? And you can say many, and I would have to agree.
The product.
Yes, first of all is the product rule. What else? What other rule has to be applied here?
The chain rule.
Yes, of course. Chain. Excellent. Great job. Thank you. So g prime of t. The first function prime is?
One.
1. Very good. Times the second function. So I'm going to copy hyperbolic cotangent of the square root of t squared plus 1. Plus, I copy the first one times. Now we want to differentiate hyperbolic cotangent. Hyperbolic cotangent. So what do I write? Times what? Let me put the formula back here. So here is hyperbolic cotangent.
Negative cosecant.
Negative cosecant.
Negative hyperbolic cosecant squared.
Of course, of this times the inner function prime. So t hyperbolic cotangent prime is this times the inner function prime. Can anyone give us the inner function prime? Anyone, please?
2t.
The inner function is the square root of a function prime. It's the square root.
That would just be 1.
The square root of a function prime. Let's go back.
1/2.
Yes, 1/2.
Square root of 2 squared plus 1.
Times the further inner function prime. Maybe you said it, I didn't hear it.
2t.
Times 2t, indeed. I will simplify this with this. So then I have the final simplified form. Hyperbolic cotangent of the square root of t squared plus 1 minus, oh, what am I doing? Minus. Everything has to be in line correctly. So minus. I have t squared hyperbolic cosecant squared of the square root of t squared plus 1 over the square root of t squared plus 1. Do not attempt to simplify these two. This is the argument of this function. It has nothing to do with something outside. So this is it. I've seen students writing something like this. Sine 2x over x, they simplify the x and they get sine 2. Please. Please. This is the argument of a function, and this is, it happens to be the same thing outside. I have another little